By now we should have an idea of how to find and what systems are alive in the network, what open ports do they have, and what services they are running. The next step is to find some holes in those services to get control over the systems. Those holes are known as vulnerabilities. Any error or misconfiguration can lead to a system breach. Unpatched operating systems or on old or unsecure network applications can become our way into that system. So in order to protect yourself, keep your software up to date. As you can see in this graphic, the total number of reported vulnerabilities in the last 10 years exceed 60,000 vulnerabilities. In each network, I'm sure that there is a lot of software older than 1 year, so for sure we can find some vulnerabilities. And I'm also sure in each company there are software from those vendors like Apple, Oracle, Microsoft, HP, and so on. Those are top companies responsible for 38% of vulnerabilities within a year. But reported vulnerabilities are not all vulnerabilities. Even when we don't know about them, there are a lot of more that are not published or they are not reported. There are several sources to check for vulnerabilities on specific version of software. Each reported vulnerability will have a CVE number to be easily tracked. So check those websites to get familiar with how to find vulnerabilities for a specific software. It will be useful later on our exploitation phase. You may say this is a manual vulnerability search. But we can also use vulnerability scanners. Those are automatic scanners tools that will look up for a vulnerability based on the open ports and services that they would discover in the network. The scans can be performed on the entire network or on specific hosts. It works on the same idea as an antivirus would by having a database with known vulnerabilities and will check the systems against them. By providing credentials with administrative rights, this tool can perform even in-depth tests. We will use such a tool in our lab. Some public accessible tools are listed here. For some of them you can obtain a trial version for testing and learning purposes. In our lab we'll learn to install, configure and use Nessus Vulnerability Scanner. This tool has a client-server architecture. This means that you can install it on a server and use a browser to connect to it from several other computers or a client instead of the browser. The scan will be performed by the server as it is configured by the auditor via the browser or the client. It uses a number of plugins depending on what we want to scan, what operating systems, what services, and so on. Those plugins are like a vulnerability database classified by the type of the target. Nessus can be also used as a port scanner. At the end of the scanning, you generate reports or integrate it with other tools to perform further attacks. On the report, Nessus will also provide the CVE number so you can research more by your own and look for exploits. There are different types of licensing for this software, but as I said, for testing and learning purposes can be downloaded for free. Please check with the vendor for further details. There are several steps to be performed when using Nessus. We will apply those steps in our future labs. As I said, the tool has a client-server architecture. So after it is installed on our server, that can be done, of course, on our attacking machine as well. We can connect to it using a browser. You have to define what you will scan, select policies that the scanner will use, and let Nessus do the rest. The scan can take from a few minutes to a few hours, depending on the number of targets and plugins used. You have access to the found vulnerabilities as soon as they are found. You don't have to wait until the end of the scanning. In this image, you have a standalone client for Nessus on Windows systems. Here is shown a part of a report for a Windows target. The latest version that we are going to use in our lab, we will use a browser as a client. MBSA, or Microsoft's Baseline Security Analyzer, is a software provided by Microsoft that can discover vulnerabilities specific only to this vendor. So just Microsoft specific software. This tool is suitable for an Active Directory environment, and it requires administrative rights to perform the tests. It has a easy to use graphical interface and can provide detailed reports about the vulnerabilities and how those findings can be fixed. Unfortunately, over 70% of security vulnerability exists at the application layer, not on the network or system layer. This is according to Gartner. So even we have firewalls, antiviruses, and other security mechanisms in place, and even the programs and operating systems are up to date, a lot of other vulnerabilities can be found on the custom applications such as websites from our servers. Here is a list of well-known vulnerabilities at layer 7 applications. Web application vulnerability is another big piece of IT security that cannot be covered only on this course. For those kind of vulnerabilities, there are specialized tools that perform the scans and recognize the findings. Some of them are already installed on Kali Linux. One of them is Nikto. This is a command line application and identifies many of well-known vulnerabilities, server misconfiguration, and default files left forgotten by the system administrators. Those files can be useful in the gathering information phase. Another advantage of Nikto is that it can integrate with Nessus, so it can automatically be launched when a web server is detected by the Nessus scan. This is an output from Nikto. No critical vulnerabilities were found, but information here can be useful in manually finding vulnerabilities related to the web server and PHP version, for instance. So we have Apache 2054 and PHP version 4.4.0. Acunetics is a commercial web vulnerability scanner, more complex than Nikto, that can perform numerous tests and is highly customizable. It has a graphical interface and can generate PDF reports with detailed information about the found vulnerabilities. Also, it provides information about how to fix those findings, and it also has a HTTP editor, HTTP sniffer, and HTTP fuzz that you can use for manual penetration testing.